The robots are not coming for white-collar work first. They never were. While every major tech publication spent 3 years debating whether AI would replace software engineers, the actual deployment happening right now is in warehouses, on factory floors, and inside logistics centers. The humanoid robot has found its first real market, not in offices, not in boardrooms, in physical labor. And the scale of what is being built and deployed right now should force a fundamental reassessment of who this technology actually threatens and on what timeline. 3 things deserve close attention. 1. Why blue-collar environments turned out to be easier to automate than analysts assumed. 2. What the deployment numbers actually look like today. 3. What the economic incentive structure means for the pace of replacement, and whether the standard argument about new jobs being created holds up under any real pressure. Start with the question most analysts ignored for years. Why would a humanoid robot be useful inside a warehouse when a fixed-arm machine or a standard conveyor system could already handle most tasks? The answer is not complicated. It is infrastructure. Warehouses, fulfillment centers, assembly lines, and distribution hubs were all designed for human bodies. The shelving units, the aisle widths, the height of conveyor belts, the turning radiuses of the pathways. All of it assumes a worker who is 5 to 6 feet tall, who can bend, reach overhead, and navigate a corner without specialized equipment. Retrofitting those facilities for conventional automation would cost significantly more than deploying a bipedal robot that already fits the existing layout without structural modification. The humanoid form factor, once dismissed as an expensive engineering vanity project, turns out to be the most practical solution to a real and costly infrastructure problem. That is not a philosophical position. It is a cost calculation. And the numbers are closing in one direction. Amazon illustrates this precisely. Bloomberg reported in 2024 that the company had begun testing Digit, a bipedal robot built by Agility Robotics, in its warehouse near Seattle. Digit was given a single task: pick up empty yellow bins and transfer them to a conveyor belt. Not exactly the vision of a fully autonomous warehouse, but the underlying logic was what mattered. The task was repetitive. The physical space was designed for human workers, and Agility Robotics built its entire commercial model around exactly those 2 facts. Digit is not being sold as a general-purpose robot. It is being sold as the only commercially viable solution for doing specific physical tasks inside environments that were never rebuilt for machines. The scale context changes the story considerably. Amazon does not have one Digit pilot running in isolation. It already has 1 million robots operating across its fulfillment network. 1 million. The Digit program is a separate layer on top of an already heavily automated system, targeting specifically the tasks that fixed machines cannot reach. The direction of travel is clear. The only variable still genuinely open is pace. Now consider the economics, because this is where the story becomes genuinely uncomfortable for everyone watching the labor market. Goldman Sachs Research revised its humanoid robot market forecast from $6 billion to $38 billion by 2035. A 6-fold upward revision, driven by manufacturing cost reductions and faster-than-expected deployment timelines. The firm identified factory settings as the first commercially viable application window, with cost per unit declining rapidly as production scales. When unit prices reach the $15,000 to $30,000 range and a robot can operate 2 full shifts without a break, a sick day, or a worker's compensation claim, the math for any warehouse operator becomes straightforward. A logistics worker in the United States earns between $35,000 and $45,000 per year, before benefits, before turnover costs, before training expenses. The economics are not ambiguous. They are already informing capital allocation decisions across the sector. Tesla has placed a significant strategic bet on exactly this logic. In early 2026, the company announced it would discontinue both the Model S and the Model X to convert its Fremont facility for Optimus robot production. That is not an incremental product update. That is a signal about where its leadership believes the near-term commercial opportunity sits. The January 2026 earnings call added honest nuance. Musk acknowledged that deployed Optimus units are still primarily in the learning phase, not yet performing productive work at scale. The ambition and the execution are not aligned yet. But that gap is the kind that closes faster than most observers expect. And here is something that rarely surfaces in public coverage of this story. The jobs being automated in this first wave are not the most precarious positions in the economy, they are the anchor jobs. The roles that historically offered entry-level stability, predictable hours, and a pathway into the working middle class without a college degree. Losing that specific tier of employment is a structural problem, not a cyclical one. It does not correct itself when the economy recovers. Here is where the honest limits of this technology need to be acknowledged, because this is a story with real constraints that deserve more than a passing mention. The same infrastructure logic that opens warehouses to humanoid robots also draws a hard boundary. Outside of structured environments, predictable layouts, labeled shelving, consistent lighting conditions, and repeatable task sequences, current humanoid robots struggle significantly. A construction site changes shape every single day. A hospital room demands nuanced situational judgment. Outdoor maintenance work involves weather variability, uneven terrain, and constant improvisation. The robots that are commercially operational today are confined to the structured end of the physical labor spectrum. That is still a very large market, but it is not the entire blue-collar workforce. The counter-argument against rapid deployment also deserves genuine engagement rather than easy dismissal. Humanoid robots have under-delivered on aggressive timelines before. That is not a fringe critique, it is a documented pattern. Boston Dynamics has been building advanced bipedal robots for decades. Atlas is a genuine engineering achievement. It is not a mass-deployed commercial product at industrial scale. The companies closest to genuine factory deployment today, Agility Robotics, Figure AI, Apptronic, are running pilots measured in dozens to low hundreds of units, not tens of thousands. The technical gap between a robot that performs one specific warehouse task at 98% accuracy and a robot that handles the full range of physical tasks a human covers across an 8-hour shift is still meaningful. But here is the dynamic that changes the calculus. Goldman Sachs reported cost reductions of roughly 40% year-over-year in humanoid robot production. If that rate is sustained, the timeline to commercial viability compresses considerably. Hardware improvement rates are notoriously difficult to project accurately. Software improvement rates, however, operate differently. Vision language action models, the AI layer that allows a robot to interpret verbal instructions, recognize unfamiliar objects, and generalize across new task environments, have improved faster than the underlying hardware. These robots are getting smarter faster than they are getting cheaper. That is a specific kind of problem, because software breakthroughs tend to be invisible until they suddenly and dramatically change what the hardware can do in a production environment. The workers most exposed in the near term sit in a specific band, physically demanding indoor work, in structured environments, at organizational scales large enough to justify capital investment. Warehouse operators, assembly line workers, fulfillment center staff. That profile describes a significant segment of the working class in industrialized economies. It also describes workers who have fewer institutional retraining pathways than knowledge workers and considerably less financial cushion to absorb a transition period of any real length. The scale of that transition is contested, but not in any direction that should inspire comfort. The World Economic Forum's 2025 Future of Jobs report projects 92 million roles displaced globally by 2030, offset by 170 million new positions, a net gain of 78 million jobs on paper. McKinsey Global Institute's range is wider and less reassuring, between 400 million and 800 million workers, potentially displaced by 2030. With up to 14% of the global workforce required to switch occupations entirely. These numbers are not a contradiction. They are measuring different things. The WEF is counting net positions across a sufficient time window. McKinsey is measuring the transition burden, the actual number of people who must find different work, build different skills, and compete in a restructured labor market while the new jobs are still being created somewhere else. The gap between displacement and reabsorption is the real risk, not the headline net figure. Policy has not kept pace with deployment, and that is the specific failure that will matter most in practice. The Bureau of Labor Statistics tracks occupational employment, but does not have a systematic real-time framework for monitoring robot-to-worker displacement. The retraining infrastructure that would need to exist, operationally, not just rhetorically, is not funded at the scale these projections imply. The WEF's 2025 report found that a significant share of employers already expect the majority of their workers will need new training by 2030. Expecting that need and actually funding the response are two entirely different policy positions, and right now they are not the same one. The honest position is this: the humanoid robot is not 10 years away from blue-collar labor markets. It is already inside them. At small scale, in the most favorable environments, with cost curves moving in one direction. The question is not whether deployment expands. The question is whether the displacement happens slowly enough for labor markets and policy systems to mount a meaningful response. History on that specific point is not encouraging. Watch the structured environment deployments. Watch the cost curves. Watch what happens when current pilots move from dozens of units to thousands. The first transition from labor surplus to displacement in a specific facility will not arrive as a news story. It will appear as a headcount reduction buried in an earnings report. That is how this has worked before. There is no structural reason to expect this cycle to be different. Facts over fear.